Current, voltage, resistance, and Ohm's law are key to understanding or describing circuit operation. This video will explain what these three electrical quantities are and how they relate to each other. In any electric circuit, electric current will flow if there's a source of electric power. But what exactly is this electric current made of? Well, the answer is electrons. Electrons are small, negatively charged particles that orbit the nucleus of an atom. In conductors like copper wire, outermost electrons break free of their orbit around the nucleus and can be made to flow through the wire. We measure current flow in amps, 6.242 billion or 10 to the power 18 electrons passing a point per second equals 1 amp of current flow. Amps are short for amperes. Electric units of measure are named after early electrical pioneers. The ampere was named in honor of André Ampere, who laid the groundwork for electromagnetism. EMF, or electron moving force, is the pressure that pushes electrons through the wire. EMF is measured in volts and is always measured across 2 points in a circuit. The volt unit of measure is named in honor of Alessandro Volta. Volta invented the chemical cell battery. Anything that gets in the way of current flow we call resistance. The tungsten filament in this light bulb has resistance and slows down the flow of current. Notice that we went back to conventional current flow, as electron flow is only used when discussing what's taking place at the atomic level. Resistance is measured in ohms. The ohm is named in honor of George Simon Ohm. Using the work of Volta and Ampere, Ohm determined and verified the relationship between current, voltage, and resistance. The formula that describes this relationship is named after him and is called Ohm's law. Let's review the electrical quantities we've discussed so far and the units we use to measure them. Electric pressure, the force that pushes electrons through a circuit, has the quantity symbol E, although V is more commonly used today. The unit for electrical pressure is the volt, and the symbol for the unit is the uppercase V. The current has the quantity symbol I, short for intensity, and the unit ampere. Uppercase A is the symbol used for the ampere unit. Resistance has the quantity symbol R and the unit ohm. And notice that the unit symbol for ohm is represented by the Greek letter omega. Quantity symbols are short form for the quantity that are used in mathematical formulas, and unit symbols are short forms for the unit. If you're interested, the convention for units named after someone is to write the unit name in lowercase and use the uppercase first letter of their name for the symbol. Ohm's law describes the relationship between voltage, current, and resistance. This circle is a common representation for Ohm's law because with it we can determine the three forms of Ohm's law. All we need to do is cover the variable we want to solve for. For example, here we'll cover up the V, and the remaining variables tell us that V equals IR, or I times R. Similarly, current equals voltage divided by resistance, or V over R. And resistance equals V over I. These three formulas are Ohm's law. Ohm's law is fundamental to electricity and electronics. Let's use the simulation capabilities of Fusion and test these three formulas. If we add parts from the NGSpice library, Fusion can simulate the circuit's operation. Here we've made a simple circuit consisting of a resistor R1 connected to a 1.5 volt power supply V1. Vcur1 is an ammeter that we've placed in the circuit to measure the current. When we simulate the circuit, Fusion will calculate the node voltages and the current measured by the ammeter. Let's check the voltage calculation using Ohm's law. Recall, V equals I times R. So, V equals 0.1 of an amp times 150 ohms, which equals the applied voltage of 1.5 volts. Here's another circuit. A 470 ohm resistor connected in series with a 120 ohm resistor. When we click on the simulate icon, we'll see the node voltages and the current measured by the ammeter of 0.020339 amps. Let's apply Ohm's law and check this current. Recall, I equals V over R. So, I equals V over R, which equals 2.44068 volts divided by 120 ohms. And so I equals 0.020339 amps, or 20.3 milliamps, matching the measurement made by the ammeter. A key thing to take away from this example is that if we know the voltage across a component and the resistance of that component, we can calculate the current flowing through the component. In the final example for this video, we'll use Ohm's law to calculate resistance. When we simulate the circuit, we see 5 volts across the resistor and 0.0116279 amps flowing out of the supply and into the resistor. Recall, R equals V over I. So in our circuit, R equals 5 volts divided by 0.0116279 amps, which equals 430 ohms, matching our circuit exactly. These three forms of Ohm's law are fundamental to understanding and analyzing circuits. It's a good idea to commit these formulas to memory. In our next video, series and parallel combinations of resistors, we'll examine the characteristics of these combinations and we'll be applying Ohm's law in the process.